Hello everyone, welcome to our online class Grade 9 Max Chapter 2 Polynomials Part 4. Before we enter in the topic, let's see the related portion in Chapter 2 Remainder theorem and examples, factor theorem and proof. Today we are going to discuss about the topic divide the polynomials. Divide the polynomials in long division method. You know very well long division in numbers it's very easy. Likewise division of polynomials also easy, but watch it carefully. Now let us consider an example to see how can divide a polynomial by any non-zero polynomial. Example 6. Divide the polynomial. So divide p of x by g of x, where p of x equal to x plus 3x squared minus 1 and g of x equal to 1 plus x. Solution. We carry out the process of division by means of the following steps. Step number 1. We write the dividend x plus 3x squared minus 1 and the divisor 1 plus x in the standard form. That is, after arranging the terms in the descending order of their degrees. So the dividend is 3x squared plus x minus 1 and the divisor is x plus 1. So the step number 1 is arranging the terms in descending order of their degrees, dividend and divisor also. Once again I repeat this. Step number 1, arranging the terms in descending order of their degrees, the dividend and divisor also. Step number 2, we divide the first term of the dividend by the first term of the divisor. So the first term of dividend is 3x squared. The first term of the divisor is x. So 3x squared by x. X term cancel, so remaining 3x. The first quotient is 3x. See in the long division table. So that is the dividend, that is the divisor. So first term 3x squared divided by x. Cancel the term, the first quotient is 3x. Step number 3. We multiply the divisor by the first term of the quotient and subtract this product from the dividend. We multiply x plus 1 by 3x and subtract the product 3x squared plus 3x from the dividend, 3x squared plus 3x minus 1. This gives us remainder as minus 2x minus 1. So step number 1, arranging the polynomial in the descending order. After that, first dividend 3x squared is divided by x, you get a quotient first term 3x. After that, you want to multiply by quotient, first quotient 3x into x. 3x into x, 3x squared. After that, plus 3x plus 1. So 3x into 1, you get 3x. So now we are going to subtract them. So 3x squared minus 3x squared, 0. X minus 3x. So x minus 3x minus 2x. So this term is 1. Step number 4. We treat that remainder minus 2x minus 1 as the new dividend. So the divisor remains the same. We repeat step 2 to get the next term of the quotient. So step number 2. So first dividend, first term of the dividend divided by first term of the divisor. So minus 2x divided by x. X term cancel, so the remaining is minus 2. So you need to write the new quotient minus 2 in the top. Step number 5. We multiply the divisor by the second term of the quotient and subtract the product from the dividend. So that is, we multiply x plus 1 by minus 2. Subtract the product minus 2x minus 2 from the dividend minus 2x minus 1. This gives us the remainder. Step number 6. The quotient of in full is 3x minus 2 and the remainder is 1. Let us look at what we have done the process above as a whole. So step number 1. So arranging the polynomials in the descending order, both dividend and divisor. Step number 2. The first term of the dividend is divided by first term of the divisor, so you get first quotient 3x. Step number 3, multiply by the quotient into divisor, so 3 into x, 3x squared plus 3x into 1, 3x. After that we want to subtract them, so change the sign. Plus means minus, minus means plus. So 3x squared is in plus, so change the sign minus. So 3x squared minus 3x squared term is 0. X minus 3x, you get minus 2x, so remaining term is minus 1. So continue the process. So now the first dividend term is minus 2x divided by the divisor, so minus 2x divided by x. So x term into x term cancel, so you get minus 2. So write in the quotient. So minus 2 after you want to multiply the divisor. Minus 2 into x minus 2x minus 2 into 1 minus 2. So again you want to change the sign. So minus means plus, minus means plus. So minus 2x plus 2x you get 0. 1 minus 1 plus 2 you get 1. So notice that the 1 is the remainder. So that 1 is the remainder, that is the quotient q, that is the remainder r. So that is g of x. Divisor is called g of x, that dividend is called p of x. So we can write as dividend equal to divisor into quotient plus remainder. So we can write p of x. So that is the dividend. P of x equal to g of x into q of x plus r of x. So p of x means dividend, g of x divisor, q of x is the quotient, r of x is the remainder. Let us see the another example for best understanding. Example 7. Divide the polynomial 3x power 4 minus 4x cube minus 3x minus 1 by x minus 1 by long division. Okay. Step number 1. So see the polynomials in descending order not. So in the given polynomial in the proper descending order. So now going to further step number 2. So divide by the first dividend by divisor. So minus 3x power 4 minus 3x power 4 divided by x. So cancel the term, you get minus 3x power cube. So that is the first new quotient is minus plus 3x cube. So again you want to multiply by 3x cube into x. 3x cube into x minus 3x power 4. 3x cube into minus 1 minus 3x cube. Change the sign. 3x power 4 minus 3x power 4 0. Minus 4x cube plus 3x cube minus plus 3, you get minus 1. So minus 6 cube. The remaining terms is minus 3x minus 1. So now going to further next process. The first dividend is minus x cube. So minus x cube divided by the divisor first term is x. Cancel the term, you get minus x squared. So now write the second quotient minus x squared. So now we want to multiply into divisor. So the divisor is x minus 1. Minus x squared into x minus x cube. Minus x into minus 1 plus x squared. So x cube minus x cube plus x cube 0. So this term is 0. So 0 plus 0 minus x squared is minus x squared. The remaining term is minus 3x minus 1. Okay, the remaining term is minus x squared minus 3x minus 1. So let us continue with the process. Minus x squared divided by x, you get minus x. So minus x into x minus x squared minus x into minus 1, you get plus x. So change the sign, plus and minus. Minus x squared plus x squared 0. Minus 3x minus x, you get minus 4x minus 1. So continue the process. Minus 4x divided by x. Delete the term, you get minus 4. That is the new quotient. The new quotient is minus 4. So now we want to multiply minus 4 into x minus 1. Minus 4 into x minus 4x. Minus 4 into minus 1 plus 4. Change the sign. Minus means plus, plus means minus. So minus 4x plus 4x 0. Minus 1 minus 4, you get minus 5. So now the remainder is minus 5. The quotient is 3x cube minus x squared minus x minus 4, and the divisor is x minus 1, and the dividend is 3x power 4 minus 4x cube minus 3x minus 1. Here the remainder is minus 5. Example 13. Factorize the polynomial 6x squared plus 17x plus 5 by splitting middle term method. Already you learned in grade 8th, so let us revise them. The given polynomial is 6x squared plus 17x plus 5. So solution. So using splitting middle term method. So the splitting middle term only used for the quadratic polynomial. The highest degree is 2, you apply the splitting middle term method. Solution. 6x squared plus 17x plus 5. So multiply the coefficient of x squared and constant term, you get 6 5s are 30. So the pairs of factors of 30 is 1 into 30 is 30, 2 into 15 is 30, 3 into 10 30, 6 5s are 30. So we want to multiply, you get 30, add them, you get coefficient of x. The coefficient of x is 17. So 2 into 15, 30, add them, 15 plus 2, 17. So use the pair of the factor of 30. So 30, 2 into 15, 30, 2 plus 15 is 17. So divided by the coefficient of x squared. Here the coefficient of x squared is 6. So you write in the denominator. So 2 by 6, cancel the term. 1 2 is 2, 3 2s are 6. So 1 by 3x. Here 15 by 6, cancel the term using the table 3. 2 3s are 6, 5 3s are 15. So 5 by 2x. So you can write 3x plus 1 and 2x plus 5. So the given polynomial p of x, 6x squared plus 17x plus 5. Factor of this polynomial is 3x plus 1 and 2x plus 15. So if you want to multiply, you get the polynomial p of x. Next, example 15. Factorize the given polynomial p of x, x cube minus 23x squared plus 142x minus 120. Solution. Let p of x equal to x cube minus 23x squared plus 142x minus 120. So factors of the minus 120 is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 5, plus or minus 6, plus or minus 8, plus or minus 10, plus or minus 12, plus or minus 15, plus or minus 20, plus or minus 24, plus or minus 30, and plus or minus 16. Suppose that a given polynomials in a quadratic polynomial, you can apply the splitting middle term method. For this case, the given polynomial in cubic polynomial. So going for the alternate method. By trial, we find p of 1. So 1 is a factor of the given polynomial p of x. So p of 1 equal to 0. So x minus 1 equal to 0. So x minus 1 is a factor of given polynomial. So let us divide the polynomial x cube minus 23x squared plus 142x minus 120 divided by x minus 1. So you know the long division method. Use the method and find the quotient. So first term x cube divided by x. Cancel the term, you get x squared. So the first quotient is x squared. X squared into x cube. X squared into minus 1 minus x squared. So subtract the term, you get minus 22x squared plus 142x minus 120. Continue the process. The first dividend is minus 22x squared divided by the first divisor is x. Cancel the term, you get minus 22x. So the second quotient is minus 22x. So now going to product of quotient into divisor. So minus 22x into x minus 22x squared. Minus 22 into x into minus 1, you get plus 22x. Subtract the term, minus 22x squared plus 22x squared 0 plus 142x minus 22, you get 120x. So the remaining term is minus 120. So now the first dividend term is 120x. So 120x divided by that first term of the divisor is x. Cancel the term, you get 120. So the last quotient is 120. 120 into x, 120x minus 1 into 120 minus 120. Cancel the term, you get 0. So the remaining term is x cube minus 23x squared plus 142x minus 120. So that is the first factor of the polynomial. P of x equal to x minus 1 is also a factor of this polynomial. So the quotient is x squared minus 22x plus 120. So now you apply the splitting middle term method, that in the quadratic polynomial. So 1 into 20, 120. Multiply, you get 120. Add means you get minus 22. So minus 12 into minus 10, you get plus 120. Add the minus 12 plus minus 10 minus 22. So the coefficient of x squared term is 1. So x minus 12 into x minus 1. So in the given polynomial, x cube minus 23x squared plus 142x minus 120, x minus 1 into x minus 12 into x minus 10. So the three are factors of the given polynomial. The given polynomial is in cubic polynomial. You apply this method. Example 15. Chapter 2. Polynomial exercise 2.4. Determine which of the following polynomial has x plus 1 is a factor. So case 1. X cube plus x squared plus x plus 1. Second one, x power 4 plus x power cube plus x squared plus x plus 1. Solve the first one. Answer: x cube plus x squared plus x plus 1. While applying the factor theorem, we get, so the p of x is the given polynomial x cube plus x squared plus x plus 1. So apply x minus x plus 1 equal to 0. So x is equal to minus 1. Apply x is equal to minus 1. Minus 1 cube plus minus 1 squared plus minus 1 plus 1. Minus 1 cube is minus 1. Minus 1 squared is plus 1. Minus 1 plus 1. Minus 1 plus 1 0. Minus 1 plus 1 0. You get 0. So we conclude that on dividing the polynomial x cube plus x squared plus x plus 1 by x plus 1, we get the polynomial remainder is 0. So the x plus 1 is a factor of the given polynomial. So now going to solve number 4. Question number 1, subdivision 4. X cube minus x squared minus 2 plus root 2x plus root 2. While applying the factor theorem, we get p of x, the given polynomial p of x is x cube minus x squared minus 2 plus root 2x plus root 2. Apply, put x is equal to minus 1. 1 cube minus 1 squared minus of 2 plus root 2 into minus 1 plus root 2. Simplify the term. Minus 1 cube is minus 1. Minus 1 squared is plus 1. Plus 1 into minus 1 minus 1. Then plus minus 2 plus 2 into minus 1. So minus into minus plus 2 plus root 2 plus root 2. So cancel the term. 2 minus 2 0. So the remaining is 1 root 2 plus 1 root 2. So you get 2 root 2. So we conclude that on dividing the polynomial x cube minus x squared minus of 2 plus root 2x plus root 2 by x plus 1, we will get the remainder as 2 plus root 2, which is not 0. Therefore, we conclude that x plus 1 is not a factor of x cube minus x squared minus of 2 plus root 2x plus root 2. Suppose the remainder is, you get the polynomial p of x is equal to 0 means that is the factor of the polynomial. Sum number 2. Use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. P of x equal to 2x cube plus x squared minus 2x minus 1 and g of x equal to x plus 1. Using the factor theorem, determine whether g of x is a factor of p of x in each of the following cases. Check sum number 1. Answer. P of x equal to 2x cube plus x squared minus 2x minus 1. The g of x is x plus 1. We know that according to the factor theorem, x minus a is a factor of p of x if p of a equal to 0. We can conclude that g of x is a factor of p of x, the p of minus 1 equal to 0. So apply, put x is equal to minus 1. 2 of minus 1 whole cube plus minus 1 whole squared minus 2 of minus 1 minus 1. 2 plus 1 minus 1 minus 1. So you get 0. Therefore we conclude that the g of x is a factor of p of x. Suppose the p of a not equal to 0 means that g of x is not a factor of p of x. Factorize. Splitting middle term method. 12x squared minus 7x plus 1. Solution. So multiply the term, you get 12. Add means you get minus 7. So we can write minus 4 into minus 3. Minus 4 into minus 3, you get plus 12. Add minus 4 plus minus 3 is minus 7. So divided by coefficient of x squared is 12. The coefficient of x squared is 12. Cancel the term, you get 3x minus 1 and 4x minus 1. So therefore we conclude that factorizing the polynomial in splitting middle term method, 12x squared minus 7x plus 1, we get 3x minus 1 and 4x minus 1. Sum number 5. Already solved this method in example 13. Sum number 5, factorize. X cube minus 2x squared minus x plus 2. So the given polynomials in the cubic polynomial. So now we going to solve using the method of example number 13. Answer: x cube minus 2x squared minus 2. We need to consider the factors of 2. So the constant term is 2. The factor of 2 is plus or minus 1 and plus or minus 2. Let us substitute x is equal to 1. So x is equal to 1. 1 cube minus 2 into 1 squared minus 1 plus 2. So you get 0. So we can take p of 1 equal to 0. So the x minus 1 equal to 0. So the x minus 1, according to the factor theorem, we can conclude that x minus 1 is a factor of the polynomial x cube minus 2x squared minus x. Let us divide the polynomial x cube minus 2x squared minus x plus 2 by x minus 1 to get. Divide the polynomial p of x cube minus 2x squared minus x plus 2 divided by x minus 1. So now you get the equation x squared minus x minus 2, the remainder is 0 because x minus 1 is a factor of the polynomial, so you get the remainder is 0. So in the given polynomial, one of the factor is x minus 1. So now we going to find out another factors of the polynomial. The given polynomial p of x is equal to x cube minus 2x squared minus x plus 2. The one of the factor is x minus 1. Now going to find out another factor of the polynomial. The given polynomial is in a quadratic polynomial. So using splitting middle term method. The coefficient of x squared is 1. 1 into minus 2 is minus 2. Multiply you get minus 2. Add means you get a minus 1. So minus 2 plus 1. Minus 2 into minus 1 plus 1 get minus 2. Minus 2 plus 1 you get minus 1. So divided by the coefficient of x is 1. So we can write x minus 2 and x plus 1. Therefore we can conclude that on factorizing the polynomial x cube minus 2x squared minus x plus 2 we get x minus 1, x minus 2 and x plus 4. Sum number 2. X cube minus 3x squared minus 9x minus 5. Now we want to find out the factorize of the given polynomial. So the given polynomial is in the cubic polynomial. So find the first factor of the polynomial. So the constant term is minus 1. So 1 into minus 5 is minus 5. The factor of minus 5 is plus or minus 1 and 5. So we want to substitute x is equal to minus 1. You get 0. So the p of minus 1 is 0. So x plus 1 equal to 0. So x plus 1 is the factor of the one of the factor of the polynomial p of x. So x cube minus 3x squared minus 9x minus 5. So we want to divide the polynomial x cube minus 3x squared minus 9x minus 5 divided by x plus 1. Now you get the equation x squared minus 4x minus 5. The remainder is 0. So the given polynomial p of x is x cube minus 3x squared minus 9x minus 5 x plus 1 into x squared minus 4x minus 5. Now we find out the factor of the quadratic polynomial using splitting middle term method. So 1 into minus 5 is minus 5. Add means minus 4. So minus 5 into 1. So minus 5 into 1 minus 5 plus 1 you get a minus 4. So the given polynomial is x minus 5 and x plus 1 is the factor of the x squared minus 4x minus 5. Therefore we conclude that on the factorizing the polynomial x cube minus 3x squared minus 9x minus 5 we get the factors x plus 1 into x. Okay students, let's do the homework based on this topic. Exercise 2.4. Sum number 1. Determine which of the following polynomial has x plus 1 a factor. Already sum number 1 and 4 is solved. Sum number 2 and sum number 3 is a homework. Sum number 2. Use the factor theorem to determine whether g of x is a factor of p of x in each of the following cases. So sum number 1 already solved, sum number 2 and sum number 3 is a homework. Sum number 3. Find the value of k if x minus 1 is a factor of p of x in each of the following cases. Refer the example number 12. So first sum, p of x equal to x squared plus x plus k. Here x minus 1 is a factor of p of x. That means p of x is equal to 0 when p x is equal to 1. So p of 1 equal to 0. So p of 1 means put x is equal to 1. X squared 1 squared plus 1 plus k equal to 0. So 1 plus 1 2, 2 plus k equal to 0, then k is equal to minus 2. Remaining sums are homework. Sum number 4, factorize. So solving the sums using splitting middle term method, already solved, first sum solved. So sum number 2, sum number 3, sum number 4 is a homework. Sum number 5. Sum number 4, refer example 13. Sum number 5, factorize. So the given polynomials are cubic polynomial. So refer example number 15. Refer example number 15. Sum number 1 and sum number 2 already solved. Sum number 3 and sum number 4 is a homework. Once again I repeat this. Sum number 3 fully homework. Sum number 4 subdivision 2, 3 and 4. Sum number 5 subdivision 3 and 4 only homework. Okay students, thank you all.